Good morning, everybody. Good morning, Facebook audience. Good morning, YouTube channel. So today we're going to continue our SAT problems, and we are moving on to solving systems of linear equation word problems. So these can get pretty tricky. It's the word problems with the dense language, the complex scenarios, not exactly the getting the equations and solving them. That's what makes these complex, is being able to understand exactly what's going on and relating that to some linear equations. So let's go ahead and jump right into it, as the morning is already 6:40, so we need to get going right away. I got the question all set up here, and you can see it's a non-calculator section. Let me clear this from 2 days ago. Oops, 7:30. What? No, not this one. Here we go. Here we go. And let's begin. The owner of a landscaping. Oh, wait, you know what? I didn't do share screen. And by the way, Facebook audience, as I've mentioned before, you can't watch what I'm doing. In order to do that, you've got to get on my YouTube channel. You can go to YouTube and search for Scalar Learning, and you can find my YouTube channel there to jump on the live stream, and then you can actually watch me solve the problems on my whiteboard. Okay, but for now, you're just going to have to listen. So the owner of a landscaping company is developing a proposal to maintain the grounds of a building. It is estimated that 75 gardening hours and 25, so here are our numbers, 75, and 25 foreman hours will be required. The total budget is $1,600. The hourly wage for a foreman is 30%. So here's the second relationship: is 30% more than a gardener, plus an additional $1.65. Which of the following systems of equations can be used to determine the hourly wages? So this is what we're solving for. G and F are the hourly wages. Okay. And basically what we're doing is we've got the foreman F, whatever the hourly wage is, we've got 25 hours being used there. And we've got 75 hours for the gardening. So we need 25 times F and 75 times G, and that's got to add up to 1,600. This is backwards. It's 25G. They said 25 foreman hours. B looks okay, at least as far as the first equation. C is also out. So, all right, right off the bat, we've got it down to B or D. It's got to be 25F plus 75G equals 1,600. Now let's get the second relationship. It says the hourly wage for a foreman is, so foreman equals, the hourly wage for a foreman is 30% more than a gardener. This actually equation, I think, is right. Hourly wage for a foreman is 30% more than a gardener. So we're increasing the gardener wage by 30% plus an additional $1.65, and that's what's happening here. It's actually, B looks good. D is flipped, so this is incorrect. They're saying the gardener, this would say the gardener is 30% more than the foreman. So we're going with B. Let's go ahead and select that and make sure we got this right. Oops. Right here. Okay. Good. Let's move on to this one. Little time crunch, so we're gonna keep it rolling. There we go. Devin is a landscaper who needs to prepare different types of grass seed for his customer's yard. Bluegrass seeds cost $2 per pound, while drought-resistant seeds cost $3 per pound. For a particular day, the two types of grass seeds totaled $68. All right, so I'm just going to say, so let's just roll with it. We don't know how much we bought of each. Let's say for drought-resistant, we'll say X, 2 of X. This is the quantity, okay, because we're looking at pounds. So 2X was 3Y, and it totaled $68. That's our first equation. Very nice. And then the second equation is that they weighed 25 pounds. So we know that the price cost $68, but remember, X and Y are just the pounds. So guess what? Here's our nice second equation. X plus Y equals 25. And then they want us to actually solve this. And I'm going to try and be a little smart with this and notice that our x is the bluegrass. So we don't need, this is just asking about bluegrass. We don't care actually about y. So if we want to solve for bluegrass, it'd be nice to, if we're going to solve this by elimination, to eliminate the y, not the x's. And it'll save us a step. So let's multiply. So elimination, the way it works is we're going to multiply the entire bottom equation by -3. Now there's a reason why I'm doing this. We got -3x. We got -3y. Equals -75. Okay. Why did I do this? Because I'm going to combine these equations now, not this one. I'm going to, because I modified this one to get this. We're going to combine this top equation and this bottom equation in a way so that the y's cancel out. We just have x's left. And look, we got a -3y and a +3y. These guys. So now we add everything. It's going to be a really nice equation. 2x plus -3x equals -x. The y's cancel out. Equals 68 plus -75 is -7. Multiply both sides by -1 and we get x equals 7. He bought 7 pounds of bluegrass. Now, isn't that cool? Because it's like once we actually get the equation set up, it's not that hard. It's just getting those equations can be tricky. Right. Again, this next problem 3, let me move it over here. Looks like we're not actually trying to solve, we're just trying to get the equations. So we have to decipher the words. All right. Let's give it a shot. Ricardo has 2 types of assignments for his class. The number of mini assignments M he has is fewer than twice the number of long assignments L he has. Okay. So number of mini assignments is 1 fewer than twice the number of long assignments. Okay. There's my first equation. And if he has 46 assignments in total, the second equation is these guys got to add up to 46. That's what it's telling us, right? We've got 2 types of assignments, mini and long, right? Is that what he's saying? Mini, and that's what they're called, literally mini and long. Bizarre names. And then now we got our 2 equations. That's it. You know, which ones work? A looks correct. Let's just make sure. B is incorrect, right? Because it's not M equals L plus 46. It's M plus L. It's different. M plus L equals 46. That's right. This one, they flipped the L and the M. That's wrong. And again, they flipped the L and the M. So it's got to be A. Let's go ahead and knock that out. Make sure we're right. And it looks good. All right. This is a non-calculator. Shouldn't need a calculator for this anyways. But this one looks pretty good. Let's see how difficult it is. Again, coming up with 2 equations. On a Saturday, a butcher sells a total of B pounds. Look, I'm going to immediately start setting this up. So the total amount he's spending per beef for the total pounds of beef is 6 times the number of pounds, $6 per pound. So I'm immediately going to start with 6B. She also sells some pork for $7. Now, they just said some pork for $7. They didn't say $7 per pound of pork. So our pork is just straight up $7. On Sunday, what is this on Saturday? On Sunday, she sells B pounds of beef again, but at the sale price of $4. She also sells some pork for $9. Given that she made the same revenue of D dollars each day, oh, well, look at that. Both of these guys equals the same total. Which of the following? That's basically it. Literally, that we've just solved this problem. And what was tricky here is that, or potentially tricky, is that they changed it up. One is pound per total. I mean, sorry, pound price per pound. The other one is just the total price, and that could easily have thrown somebody off. And if you didn't pay very, very close attention, this is it. Our work is done. So now we just match them up with the right thing here. This is all messed up because you can see they have a 4B matched up with the 7. That's not right. Here they have a 6B with the 7. This one, B looks right. This one, they've moved things around. Let me just make sure that's not right, because then they done. Why are they multiplying the D by 4? That's wrong. And again, so the D, so those are both clearly wrong because the D is the total. Multiplying it by 6 and 4 makes no sense. So B should be our go-to here. And we got our last one, number 5. Okay. Number 5. All right. Final one. Piece of glass with an initial temperature of 99 degrees is cooled at a rate, 99 degrees initials, cooled at a rate of 3.5 per minute. I know that means the temperature is dropping by 3.5 degrees per minute. I'm going to use M, and I can see quickly they use M here. And that's my temperature, okay? Starting at 99, number of minutes times 3.5 is how fast it's cooling. And then currently a piece of copper with an initial temperature of 0 degrees is heated at 2.5 Celsius per minute. And that's its temperature. Which of the following systems of equations will solve for the temperature in degrees Celsius and time M when the glass and copper reach the same temperatures? We're done. These are our equations. So we were able to kind of create them as we were reading. And that means our answer is not A. It's not plus 3.5. It's minus. Because cooling is implied that the temperature is dropping. It is this one. They don't have the 0, but it looks like it's going to be B again. A lot of B's. And then this one's wrong. That would be an increase of 2.5. The top equation's right. Oh, no, it's not. Neither of them. They switched the 2.5 and the 3.5. Let's go ahead and go to B. And there we are. There we are. Okay. Let's go back to share screen. All right. Cool. So good stuff. Hopefully that was helpful, and we'll continue with this tomorrow. And again, Facebook guys, if you want to really watch these videos and watch me actually solve them on the screen, go to my YouTube channel, subscribe. You'll get a notification every morning when I'm doing one of these videos, one of these Khan Academy sets live. And you can follow along and check it out. Thank you guys so much for joining, and I will see you guys next time. Take it easy. Whoops.